right, guys. So I'm back here. Let's find some areas. So we have a couple pages of areas. Again, you can kind of hear my voice is going out. My throat's starting to hurt from just a bunch of talking on these videos. And so I'm going to show you the first couple areas, and then I'm going to just write the key for the other two. Right now, let's go ahead and establish that we're going to go ahead and cancel this one out. There's a couple different reasons why, but we're just going to go ahead and kill that one off and omit it from like the set of problems. This still gives you plenty of practice with areas, but that one just it's not worth. It was one we were going to cover, but we decided not to, and I forgot to take it off the review. All right, so no big deal. Let's go back here and find areas. Let's first establish what we have to do. So areas are born from formula, but all the formula are basically the same. We have to multiply two values, but those values have to be at right angles to one another. There's lots of good reasons why, but in the end, that's kind of the case. And so all formulas really are either just base times height, as long as the base and height are at right angles to one another, or base times height divided by 2 in the case of a triangle, because a triangle is technically half of a quadrilateral. All right, so that's how we're going to approach this one. We have a rectangle, and so we know the area formula, as I switch to my drawing tool, the area formula is just going to be base times height, or length times width, or any kind of derivation thereof. Okay, and so again, the only rule is that the base and the height have to be at right angles to one another. And so we have to find some length, which means we're going to find distance, but we don't have to find all the distances, just 2 will suffice. So like that can be distance 1, and as long as this one's at a right angle, which it totally is because this is a rectangle, that will be our second distance, and that'll be our base and height, okay? And so let's declare this to be our red value and this to be our blue one, just for organizational purposes. But in terms of finding distance, like the rules don't change here, 1, 2, 3, 4, and so I can use whatever technique that I want. So I'm going to use Pythagorean theorem, okay, so to find the base, okay, which is BC, I'll just take a squared plus b squared is equal to c squared. So I have 1 squared plus 4 squared. Okay, so that's 1 plus 16. Okay, and of course we'll square root to find our value. All right, so we have our C value, which is approximately 4.123. Okay, so we have our base. Okay, so we have BC. Now we just have to find something, an adjacent side that is perpendicular, and an intersecting side that's perpendicular. But since we just need distance, we don't have a new technique. 6, 7, 8. We just simply have distance formula or Pythagorean theorem. Okay, so to find the height, okay, which is going to be, what's that, DC. So 4, 8 squared is 64. All right, so of course we'll square roots to get rid of the square, leaving us with a value of 8.246. Okay, so we have the components we need. We don't have to find anything else because we're finding area, not perimeter. And so we can go to our formula, base times height is going to equal our area. Okay, so then we have 4.123 times 8.246. Okay, so I have approximately, well, not 0, 4.123 times 8.246, and so we have 33.998. All right, so again, this is one of those problems where it's just disguised. Like, you have to find the area. Okay, you've done that 100 times. So you have to know how to find the pieces you need for area. In this case, you need to find two perpendicular side lengths. Being a rectangle, we know all the sides are perpendicular, so just pick two. As long as they meet at a right angle, they can serve as a base and height, and the area is gonna be 1/2 base times height. All right, so going on to our triangle, excuse me, we have a different formula for a triangle, but it's still multiplication. So we have the area is equal to 1/2 base times height. And that's just a known formula. And so if you're thinking, oh, did we miss a day or something? No, but finding area of a triangle, that's middle school stuff. So it's perfectly acceptable for us to assume that you know how to find that area. Okay, so 1/2 base times height. Again, the rule is the base and the height have to be at right angles to one another. And so I have one right angle shown. And so I can take AB to be my base. That's going to be AB. What is going on with writing B's today? Okay, and the height is actually going to be this distance. Okay, oh. Okay, and the height's going to be DC. All right. So these are just distances, and so again, our methodologies will not change. Since I've been kind of going back and forth, I'll use distance formula here. And so the distance AC is equal to the change in x squared plus the change in y squared. Yeah, that's just x2 minus x1 squared and y2 minus y1 squared. I'm just using the shorthand form because subtraction always finds a distance. So my x's go from -6 to +6. That's a change of 12. Okay, at the same time, we're going from we're going from 4 to 7. That's a change of 3. Okay, so 4, 5, 6, 7. All right, I don't know why I changed to blue. It is what it is. Okay. Let's go back. 4 to 7, that'd be 3 squared, okay. All right, so 12 squared is going to be 144 plus 9. So it's going to be, 153, which approximates under a square root 12.369. Okie dokie. So let's now find our height. So it's going to be DC. Change in x squared goes from 2 to 4, so that's a change in 2. 6 goes to -2, that's a change, in this case, of -8, although the direction of change doesn't matter because we're about to square it. So that's 4 and 64, so that's going to be 68. And the square root of 68 is going to be 8.246. All right, so now we have all we need to operate our formula. So let's get that going. Okay, so we have 1/2. The base in this case is 12.369. Okay, the height in this case, 8.246. Okay, so our area, once multiplied all together, oh man, I hate that. This stupid board and this crazy program. Stop writing non-equals. All right, here we go. So we take 12.369 times 8.246, then multiply by 1/2, and our area is approximately 50.997. Okay, now that of course is arbitrary. Like, finding areas finding perimeters. The real question is, how do you find the lengths that you need, and can you get those lengths accurately? In the case of perimeters, we're finding side lengths, all the side lengths, and so it's just straight up Pythagorean theorem and distance formula. In the case of area, it is length again, but those lengths have to be at right angles. And excuse me, so it's just not any length, it's the correct lengths. Same thing here, okay? So this is where this video is gonna end. Although we do have one more area problem, again, I need to try to save my voice because we do have proofs still to do. And so I'll, of course, write out the key for that, but this is where the video is gonna end, okay? I'll see you guys in proofs.